Welcome, explorers, to Virtual MOSI. My name again is Catherine, and today what we're dealing with is all about combustion reactions. This is the final installment of our chemistry week, and what I want to start with is the three main ingredients that you need for a combustion reaction. Can you think of what you need for a combustion reaction? Remember, combustion is just a fancy word for fire, and we need three things for that. You might have seen two of them just now. I have a fuel source. This here is our special MOSI sauce, a proprietary blend that we make here in the lab. You need a heat source or a spark, which we have. And of course, most importantly, you need oxygen. We have plenty of that in the lab right now. So, theoretically, if we have all three of those things, we should be able to make some fire. Get that going there. These are our special lab tables that we have here in our steam lab. And they are designed to withstand everything from fire to explosions to chemical reactions and everything else. And at the end, we'll show you a couple other cool things about our lab. But let me do another activity really quick. Oh no, it looks like we're running out of our fire. What happened? We must have run out of one of our ingredients if the fire is going out. I still have my heat source, and if I try to light it again, nothing. We still have our oxygen, pretty sure. So we must have run out of our third ingredient, right? Fuel. Now, fuel can be anything from MOSI sauce to wood to charcoal. There's a lot of different types of fuel. And let's put some more of the MOSI sauce here into our famous whoosh tube. I'm going to put quite a lot in here. And you're going to have to pay close attention when I do this because the reaction happens very, very quickly. I'll put some right at the top and we'll zoom in close so you guys can see. And 3, 2, 1. Whoosh. And again, our fire went out. What do you think happened this time? Did we run out of the fuel again? One of the ingredients must be done. Still have my spark. Ooh, a little bit more fire than I expected. And that's why when I do this reaction, I make sure that I have all the proper safety equipment. I have my safety goggles, I have my fire extinguisher here, and of course I'm doing it on these flame-proof tables. So we definitely still have heat, and I'll bring this closer to you guys. If you look closely, you can see in the bottom, I have an awful lot of fuel still left. So that must mean we ran out of one of our other ingredients. And in fact, we ran out of oxygen in this case. That's why if I try to do it again, I'm not going to get much of a result. It's not going to be as dramatic as that first time. It's hovering near the top where there's a little bit of oxygen still left. So if I want to do it again, I need to kind of wait for this to refill with oxygen, kind of pump it back up, and even then it takes quite a long time. Luckily, I have another tip for you guys. Just in case you didn't see it the first time, I know it was pretty quick. I want to do it again for you because it was really, really cool. And we have a slow motion version of this on our website if you want to check it out, over at MOSI in Motion. Let's see if we can get another good whoosh. Are you ready? Count down with me. 3, 2, 1. Awesome. Cool. So again, ran out of oxygen. We still have plenty of fuel in the bottom. And a combustion reaction is one type of chemical change. Remember yesterday in our lesson we talked about the difference between physical changes and chemical changes. Physical changes change the shape or the form perhaps of our substance, but it remains the same on a molecular level. Imagine ripping a piece of paper in half. A chemical change, on the other hand, is something that changes the substance on a molecular level. So those molecules are breaking apart, ripping up, and forming new things. Imagine a match burning, for example. You can't get a chemical change back to the way that it was before, the way you might be able to do with a physical change by taping that paper together or something like that. And in fact, there's a couple different clues about chemical changes, and you might have noticed a few of them while I was doing my reactions here with the fire. We have definitely a change in heat, is one of the clues that there's a chemical change taking place. We have a change in color, and we have a change in smell. And all of these experiments that I'm doing today, please, disclaimer, do not try them yourself at home. They take a lot of specialized training here. So we've got some fire in some of these. I've got a fuel source already. There we go. And what I have is a special fuel here. I might need to add a little more fuel to these so you can see them. And what I'm going to add to each of these fuel sources is a different chemical into each different petri dish. And they're all variations of salt. So this first one that I have here is just regular old table salt. And you can see, as I add it to the flames, they turn this nice orange color. Versus, I have a different salt here. This one is made with strontium chloride instead of sodium chloride. And when I add it to the fire, it burns this nice red orange. It's much more vibrant. And then moving on to this one, let's see if it's still hot. No, it is not. We'll light it again. Still nothing. All right, there we go. As we add this one, it's going to be a little bit more of that purplish color, that blue. Can you see that? This one is potassium chloride, and that's a really cool color. Now, what I'm doing here is actually something that scientists occasionally perform in a lab called a burn test. Different chemicals burn different colors due to their chemical makeup. So, let's see if we can get a nice, I think this one should be pink. There we go. This one is lithium chloride, extremely volatile substance. So we have to be careful with it. And yeah, scientists can do these things called a burn test to figure out what chemical they have by burning it. But it's not only a good investigative technique. There's another place where we like to burn different chemicals to get different colors, and I bet you've seen them before on the 4th of July. One place that we use all these different chemicals to get different colors is fireworks. So if you want to be a scientist who does pyrotechnics and things like that, you're going to need a lot of chemistry experience. Love it. Kind of mix them all together. This is one of my favorite experiments to look at. It's very, very cool. All right.
Is it possible to make a purple fire?
So this is about as close as I've got with my substances, with the potassium, for that nice bluish purple. I'm not familiar with which chemical might burn purple, but every single different salt is going to burn a different color. All right. Now I have another thing that I want to show you guys here. One more combustion test. So this is some lycopodium powder. Lycopodium powder is just a powder that we make with a special type of moss. And it's very, very, very fine. Let me make sure I put out this green fire before I move on to my next experiment. Okay, so if you can get a good view of that fine lycopodium powder, we've got our heat source, we've got oxygen, and we've got a fuel. It is very flammable, as you can see from my warning sign here. So let's see what we can get. Nothing. Any ideas why it's not lighting on fire? We have all three of the ingredients. I'll give you a hint. We have plenty of heat, we have plenty of fuel, but because these particles are so, so fine, the oxygen molecules actually cannot easily get in between them. So it's very hard to ignite it when it's all tight together like this. But I do have a special trick to actually make it a little more of a bang. And I'll light this candle here. I'm going to add some lycopodium to this pipette that I have. And what I'm going to do is I'm just going to push this out over the flame, and that's going to allow the lycopodium to spread out a little bit, let those oxygen molecules get in between, and we'll see if we can get it to light now. Are you ready? Count down with me at home. 3, 2, 1. All right, let's do it again. I figure if it's cool enough to do once, it's cool enough to do twice. 3, 2, 1. One more. I think I have a little bit left in here. 3, 2. Nice. Any extras? There we go. And fine particles are something that we have to be careful about in situations like grain silos or flour mills, places like that, where these tiny fine particles get so spread out into the air they can actually become more flammable. All right. So I mentioned earlier that you shouldn't be doing this activity at home. This is something we've been trained to do. We have the proper safety equipment to do. And we're doing it here in our STEAM lab. Since it's Field Trip Friday, we thought we'd show you a little bit more about the lab that we have. This is where we do all of the activities and experiments that maybe are our most extreme, that we can't easily do in other places. And we have a lot of equipment here to help us do that. So we have, for instance, not only our excellent chemistry sinks with different gas hookups, we have, of course, our safety first aid kits, and kind of do a search and find, see what you can see around the lab. We've got all kinds of things like rockets, and we've got Mediman over here that we use for our first aid training and different health kind of exhibits and lessons that we do. We have, of course, our fume hood as well. This is where we can do our most volatile chemistry experiments, things that are going to produce fumes that might not be safe for us to deal with. We can do right in here. And, of course, we have all of our microscopes and different types of samples of fossils and bones and different cool things that we can show you when you come and visit us. All right. And of course, every lab needs to have an eye wash station, just in case you get anything in your eyes. You can quickly go over there and take a shower, wash your eyes out, and it is very, very powerful. We actually had someone pull that accidentally one time, and it flooded the whole lab. So it is very, very strong. All right. I want to do one more thing to kind of take us out. You got to see some of those different salts earlier. And you know that they make different colors. And you can actually mix them together safely to get what I like to call a rainbow flame. So let's see. Put a little bit of regular table salt just for good measure. And we'll do the same thing that we did at the beginning. Remember, we have our fuel, we have our oxygen, and we have our spark. Let's get quite a bit there. And let's see if we can't make a rainbow flame together before we go. Too, what your favorite color that you've seen that we've done today was. I'm very partial to the green flame myself, but the pink is also very nice. And it's kind of like fireworks right on our table. Remember, please do not try these experiments at home. They are quite dangerous, and you probably don't have the materials to do it, at least in the case of these salts. So, be careful out there. Thanks for coming on a quick tour of our lab, and as always, keep discovering.